This is the Algebra 1 CBA review. Question 1 says, what is the value of m that makes the following equation true? So the first step to solving an equation is always to eliminate the parentheses, and we don't have any. So the second step is to combine like terms. So I see that I have a 2 and a negative 9 that I can combine. 2 minus 9 is negative 7. The second step is for me to move my variable to the left. So I see a positive 12m, so I can subtract 12m from both sides of my equation, and I'm left with negative 7 minus 7m is equal to 14. Next, I'm going to add or subtract my constant to the right. So I have a negative 7, so I will add 7 to both sides, and I'm left with negative 7m is equal to positive 21. Last, I'm going to multiply or divide so I can get my variable isolated, and I will divide both sides by negative 7. Positive 21 divided by negative 7 is negative 3. So I'm going to go to my calculator and I'm going to check this answer because it says that this equation should be true. So both sides should be equal. So I'm going to type in my equation, and instead of m, I'm going to put my solution for m. And it says true. Another way to do this is to put both of the sides of my equation in separately. And see that they are both equal. The equal sign is right here when I'm typing, right under control. Okay, number 2. Same thing. I'm going to combine like terms. So 13 minus 3 is 10. Although these sides look very, very similar, and you might be thinking infinite solution or no solution, I have a 5 and a 15. Those are different. I have a positive 10 and a negative 10. Those are also different. So next, I'm going to move my variable to the left side of the equation. This 15 is positive, so I will subtract. 5m minus 15m is negative 10m. Next, I have a positive 10 over here on the left, so I'm going to subtract 10 from both sides. So I have negative 10m is equal to negative 20. And last, I'm going to divide both sides by negative 10. And m is equal to positive 2. Again, I'm going to take my calculator and I'm going to check this answer. So I have 13 plus 5 times 2 minus 3. Sorry, you can't see it. Is equal to 15 times 2 minus 10. Again, it says true. Okay, number 2. What is the solution to the following equation? Again, same exact thing. I'm going to figure out what k is equal to. I'm going to isolate my variable k. So this one I do have parentheses. So I'm going to eliminate my parentheses by using the distributive property. 10 times k is 10k, and 10 times 3 is 30. I'm really distributing a negative 1 over here. Negative 1 times negative 9k is positive 9k, and negative 1 times negative 4 is positive 4. In the next step, I'm going to combine my like terms. So I have terms that have k, and then I have terms that are constants. And then I also have terms that are constants over here. So 10K plus 9K is 19K. 30 plus 4 is 34. Nothing to combine that K with. And I have negative 5 minus 3 is negative 8. Next step, I'm going to move my variable to the left. This K is positive, so I will subtract K from both sides, leaving me with 18K plus 34 is equal to negative 8. Next, I'm going to add or subtract my constant to the right side. So since it's a positive 34, I'm going to subtract 34 from both sides. So I'm left with sorry about all this noise. I don't know what the custodians are doing in the hallway. Okay, 18K is equal to, and then negative 8 minus 34, of course, is negative 42. Last step is to divide or multiply to get the K isolated. This time I will have to divide since 18 and K are multiplying, and negative 42 divided by 18 is not a whole number. So I'm just going to have to simplify my fraction. Both 42 and 18 are divisible by 2, so I can make that negative 21 over 9. I can actually keep going there because both of those numbers, my numerator and my denominator, are both divisible by 3, so that's negative 7 over 3. So there's my solution, and now I'm going to check. So I have 10 times the quantity, negative 7/3, plus 3, minus the quantity, negative 9, times negative 7/3, minus 4. What does it tell me that is? Negative 31/3. Interesting. Okay, next side is negative 7/3 minus 5 minus 3, which is also negative 31/3. They're the same. So I got it right. Even though it's a crazy answer, I can definitely check it. Okay, let's look at 2B. Again, distributive property with my 2. So 2K plus 8. I'm technically distributing a negative 1 here. Negative 1 times negative 8K is 8K. And negative 1 times negative 5 is positive 5. Okay, next I will combine like terms. So I have terms that have K. And then I have constants. I have constants over here as well. So 2K plus 8K is 10K. 8 plus 5 is 13. Nothing to combine that 7K with. And negative 4 minus 1 is negative 5. Next, I'm going to move my variables to the left. I'm sorry. Yes, to the left. So on the right, I have a positive 7K. I will subtract 7K. 10K minus 7K is 3K. Then I will add or subtract my constant to the right. So that's minus 13. So I am left with 3K is equal to negative 18. And divide both sides by 3. So K is negative 18/3. So let's use our calculator and double check this answer. Okay, so I have 2 times the quantity, K plus 4, minus the quantity, negative 8 times K minus 5 is equal to 7K minus 4 minus 1. Oh, I don't want that. Nope, true. Awesome. Okay, the next section are literal equations. So in a literal equation, I'm not going to get an answer like I got in 1 and 2 because I have multiple variables. I have x and I have y. Those are not the same variable and they can't combine. So I'm just going to get this y by itself. I'm going to get this y by itself. So I have to still use my inverse operations and still isolate this y. So I see a plus 3, I'm going to subtract 3. I can only subtract with like terms. So I'm not writing the minus 3 under the 2x. Those aren't like terms. I'm writing the minus 3 under the 7. So this becomes 2x plus 4 equals 3y. Technically, that's 3 times y. Whenever I have a coefficient right next to a variable, it's multiplication. So I'm going to divide both sides by 3. So y is equal to 2x plus 4 divided by 3. Now you can get fancy and actually divide each of those terms by 3 if you'd like, because sometimes we will get something that will reduce. Not on this example, but it happens. Okay, same thing over here. We are trying to get this y alone. So I will subtract 2. 4x plus 4 equals 5y. 5y means 5 times y. So I'm going to divide both sides by 5. And I have y is equal to 4x plus 4, all divided by 5. Or if I want to get fancy, I can actually divide both of those terms by 5. Again, nothing simplified here, but sometimes it will. Same type of thing over here, but the x and the y are on the same side of the equal sign. So we will have to, when we isolate y, we actually have to get rid of this 2x, which is positive. So I'll have to subtract 2x from both sides. Now, what's different about this example is that these are not like terms. 14 and negative 2x cannot technically be combined together because they're not like terms. 14 doesn't have an x and the negative 2 does. So I just have to write them next to each other. I could write 14 minus 2x, or I can write negative 2x plus 14. It's the same thing. Again, 4y means 4 times y, so I'm going to divide both sides by 4. So this is a perfectly acceptable answer to leave it like this, or we can actually write this as 2 separate fractions. And we do see some simplification that can happen here. Negative 2 over 4 is negative 1/2, and 14 over 7, that's not supposed to be a 7. That was a 4. How did I do that? So that doesn't simplify evenly, but both of these are divisible by 2, so that's 7/2. So these are both acceptable ways to write our answer. Okay, very similar in the next one. Again, we're getting this y by itself. So I will subtract 8x. Not like terms here. And then I'll divide everything by 2. Here we see lots of cancellation, lots of simplification. So I can leave it like this, or I can actually divide. Negative 8 divided by 2 is negative 4, and 10 divided by 2 is 5. So multiple ways to write my answer there. Okay, and number 5, we are writing an inequality that describes all the solutions and graph it. So we don't just get an answer of m equals this or n equals that because we have an inequality. We know that we have a whole solution set of numbers that are either going to be bigger than m or less than m or maybe even equal to m as well. This one we only have a greater than symbol. So when I graph it, I'm going to have an open circle. Same rules apply from all of the solving that we've been doing. I do have to eliminate parentheses first, so I'm going to use distributive property. So 5 times negative 6 is negative 30, and 5 times 3m is 15m. Moving my variables to the left side of the equation means I'm going to have to subtract 15m from both sides. So I have 26 minus 14m is greater than negative 30. So the next thing to do is going to be to move my constants to the right. This 26 is positive, so I'll have to subtract. So I have negative 14m is greater than negative 56. Okay, so last thing to do is to divide by negative 14. And when I divide or multiply by a negative number, I need to switch the direction of the sign. Negative 56 divided by negative 14 is positive 4. Notice I changed from greater than to less than. So on my number line, 4 would have an open circle and I would shade less. So let's test out an answer. 0 is a very easy thing that I shaded over. So let's double check that. If I plug a 0 in for m, and I could plug anything that's less than 4 in, but I'm doing 0 because that's easy. 26 plus 0 is 26. If I make this a 0, 3 times 0 is 0. So all I'm doing is multiplying the 5 times negative 6. So is 26 greater than negative 30? It sure is. Okay, similar problem over here. I'm going to distribute my 4. So I have 16 plus m is greater than negative 12 plus 8m. In order to isolate my variable, I am going to subtract 8m from both sides. So I have 16 minus 7m is greater than negative 12. Subtract 16 from both sides. Negative 7m is greater than negative 28. At this point, when I divide both sides by negative 7, I'm going to have to flip my sign from a greater than to a less than, and negative 28 divided by negative 7, again, is 4. So I have an open circle at 4, and I'm shading less. Again, I'm going to check my answer. I'm going to pick 0. It's the easiest thing to pick. So 16 plus 0 is 16. If I make this m a 0 as well, 2 times 0 is 0. So all I need to do is 4 times negative 3, which is negative 12. And that inequality is true. In number 6, I do have to combine my like terms before I start. Oh, hello. I do have to combine my like terms before I start to solve. So I have negative 3 plus 2, which, goodness gracious. Negative 3 plus 2 is negative 1. Add 1 to both sides. I'm isolating my variable. Negative 1 plus 1 is 0. Divide by 2 and is greater than 0. So unfortunately, I cannot check my answer using 0 here because 0 is what I need to be greater than. So I'll pick the next best thing. I'll pick 1. Let's test that out. 2 times 1 minus 1 is greater than negative 1. 2 times 1 is 2. 2 minus 1 is 1. Yep, that's true. Okay. Same type of thing over here. 2n minus 4 is greater than these like terms combined to negative 10. Add 4 to both sides. 2n is greater than negative 6. Divide both sides by 2. N is greater than negative 3. You may be wondering why I'm not flipping my sign because I have this negative 6. I'm not dividing or multiplying by a negative number. The negative 6 is what's being divided. So no need to flip your sign. We have negative 3. Ooh, I can use 0 this time. Great. and I'm greater than -3. So let's use 0. I like that. 2 times 0 is 0, minus 4 is -4. Is -4 bigger than -10? Absolutely. Because if I think about my number line, -10's over here, -4's over there, 0's here, and whatever's on the right is bigger. Okay, number 7. Write an inequality that describes all the solutions and graph it. So again, using distributive property, 3 times a is 3a, 3 times 5 is 15, -4 times 3a is -12a, and -4 times -6 is +24. I'll have to add 12a to both sides to get my variable onto the left. So that's 15a plus 15 is greater than or equal to 24. Subtracting my constant from both sides, 15a is greater than or equal to 24 minus 15 is 9. Divide both sides by 15, and a is greater than or equal to 9 over 15. Both of these are divisible by 3, so I can make that 3/5. Where's that on my number line? Pretty much a little bit bigger than halfway between 0 and 1. So because I have a greater than or equal to, I have a closed circle and I'm shading to the right. So I can't use 0 as a test point, but I'll use 1 because that's not too bad. So if I use 1, that's 3 times the quantity 1 plus 5 is greater than or equal to -4 times the quantity 3 times 1 minus 6. That's a little complicated, so let me use my calculator on this one. Okay, so 3 times the quantity 1 plus 5 is greater than or equal to, so I'm going to go Control Enter. So I have the greater than or equal to sign. -4 times the quantity 3 times 1 minus 6. True. Awesome.